Start with the square whose side length is equal to 50. Then consider a right triangle whose legs have lengths equal to 40 and 30. 4 copies of this triangle are placed in the 4 different corners of the square. Each time the triangle is rotated 90 degrees as shown. The triangles do overlap each other. The question is, what portion of the square is not covered by the 4 triangles? In other words, what is the area of the region shaded in green? I thank Jumer for the suggestion. Pause the video if you'd like to give this problem a try, and when you're ready, keep watching to learn how to solve this problem. I will first review a principle of similar triangles, and then I will present a solution of the problem. First, similar triangles. As Euclid said, similar triangles are to one another in the squared ratio of their corresponding sides. If 2 triangles are similar in sides by a ratio of x, then the areas of these triangles will have a ratio that's equal to x squared. Now we've all seen this formula before, but why is it true? Let's quickly go over a justification. If the 2 triangles are similar with their sides in a proportion equal to x, then the heights of the triangles will also be in a proportion that's equal to x. The first triangle has an area that's equal to its base times its height all over 2. The second triangle also has an area that's equal to its base times its height over 2. But this time the base and the height are both scaled by x. Therefore, these multiply together to be x squared. So the area of the second triangle is exactly equal to the area of the first triangle multiplied by x squared. This justifies the principle that if the triangles have sides in a ratio equal to x, their areas will be in a proportion that's equal to x squared. So now I will present a solution to the problem. So here's our diagram. Now let's do a little bit of transparency on the triangles to see what's going on behind them. Notice there are 4 overlapping triangles. So in order to figure out the areas of these triangles, let's focus on one of the original right triangles. Since its legs are equal to 30 and 40, its hypotenuse will be equal to 50 because it's a 3, 4, 5 right triangle scaled up by 10. Now, suppose this triangle has angles that are equal to A and B. In the adjacent corner, this triangle will also have angles equal to A and B, but it'll be rotated by 90 degrees. So A will be here and B will be over there. So now let's focus on this overlapping triangle. Notice that it's also a right triangle with angles equal to A and B. Therefore, this purple triangle is similar to the blue triangle. Furthermore, we can figure out the length of its hypotenuse. Now this distance here will be equal to 50 minus 30, which is equal to 20. Then the longer leg of this right triangle is equal to 40, so this distance, which is the hypotenuse of the purple triangle, is also equal to 20. Then the remaining length here will be equal to 10. Now let's figure out the area of the larger triangle. It has legs equal to 30 and 40, so its area will be equal to 30 times 40 over 2. Thus, it's equal to 600. Now the similar triangle, which is smaller and purple, this will have an area that's 600 multiplied by the square of the ratio of the lengths of the hypotenuses. So it'll be 600 multiplied by 20 over 50 squared. So this will be equal to 600 multiplied by 2/5 squared, and that is equal to 96. So we figured out the areas of these triangles, and now we can solve the problem. We'll go back to the original diagram, and then we have 4 of these overlapping triangles. So the area that's shaded in green will be equal to the area of the entire square minus 4 times the area of the blue triangle plus 4 times the area of the purple triangle. Now the area of the square is equal to 50 squared, which is equal to 2,500. Now we just need to simplify. We have 2,500 minus 4 times 600 plus 4 times 96. We go ahead and do some arithmetic, And then we do some arithmetic again, and we get the area of the region shaded in green is equal to 484. And that's the answer.